Welcome back, folks. In this particular video, we're going to be taking a look at your first hop redundancy protocols, namely HSRP and VRRP. There's no such protocol as FHRP, but it is a type of protocol that we're going to be discussing in this particular video. The following videos will be actually taking a look at the implementations of it, but let's get started with the concept first, the technology first, so that we can then take a look at the actual implementations. FHRP, I'll give you an overview what this type of technology brings to the table, and the two main implementations of FHRP, which are HSRP as well as VRRP. Just to give you a heads up, HSRP is a Cisco proprietary implementation. Just like with the other technologies, VRRP is the open standard version of it. All right, but before we get into that, let's go ahead and take a look at what does FHRP bring to the table. We have taken a look at different type of redundancies up until now. We took a look at redundancy at the routing protocol level, where you might have multiple different routers allowing one router to talk to another router using the concept of load balancing or ECMP. So if I had one router over here which has multiple equal costs, and in case of FHRP, it also gives you unequal cost load balancing, I have the ability, based on my routing protocols, to implement load balancing. So if I want to get from router 1 to, let's say, network 192.168.4.0, I have two redundant paths to get there. The two redundant paths being via R2 to R4 or R3 to R4. So that was redundancy between different routers running a routing protocol. We took a look at that. The next level of redundancy that we saw was between two different switches. You have switch 1 connected to switch 2. If I wanted two links to be connected to each other, we looked at a technology by the name of ether channel or port channel, whichever you prefer to call it. Which allowed us the ability to do load balancing at layer 2 between the two different switches. All right, so another form of redundancy. So what does FHRP bring to the table? What's the purpose of FHRP? FHRP provides redundancy at excuse me, at the first hop level. What does that mean, first hop? I'm going to bring this topology in front so you guys can take a look at it. Now, for a minute, let's assume that I don't have this particular router over here. Router 5 does not exist. I want this PC3 over here to be able to go out. And my default gateway configured on PC3 is the IP address of this guy. Let's say assume it's 192.168.20. Let's put this as .4. So when I configure the IP address over here, let's say it's on the 192.168.4 network, and let's say it's 51/24, and my default gateway in that case would have been 192.168.4. Let's say 4. If this router goes down, the entire segment of any devices that are hanging off of that 192.168.20 network, I've lost connectivity to the rest of the network. So to counter that, I can go ahead and put two routers to allow me to go out to the other network. So now I have two IPs over here, .4 and .5. But that, having said that, my default gateway is still pointing to R4. What if 4 goes down? All the PCs in this particular network, they will have a default gateway still pointing to .4. So I would need to go to each and every PC and change the default gateway manually to where? To .5, or have them renew their address through the DHCP server to .5. Either way, I need to reset my configuration to do that. And that's where FHRP works at. It works as a way to provide your first hop for your device, for your end device, the first hop redundancy. So from the perspective of the PC, the redundancy at the first router level. and that's done through FHRP, First Hop Redundancy Protocol. All right. So let's take a look at the slide. What does the slide have to say for this? And then we'll go ahead and take a look at the implementation of it. So in order to provide redundancy between two switches, you connect two or more links between them and use ether channels. We also took a look at the ECMP part, which is between routers. Similar to provide redundancy for your clients, from your clients to exit your network to provide two different exit points. That's where FHRP works. It doesn't work with the PCs. Instead, what it does is it allows you the ability to set up a protocol that would allow these two routers to talk to each other. What they do is they share a common, they have their own individual addresses, but they also allow us the ability to share a common virtual IP that both of them will share. Although both share it, in addition to the IP address, they'll also share the MAC address, a virtual MAC address running between RX and RY. Although they're sharing it, besides having their actual addresses, the address that is individually assigned to RX and RY, or the MAC addresses of RX and RY, they will share this address. Although they're sharing it, one of them, only one of them will be the active forwarding router. Active router, or we call it master or forwarding router, it's only going to be one of them. Whoever is the active forwarding router is the one that is going to answer for this virtual IP. So if he's the active router, I will send my traffic to RX. For these guys, their default gateway is not .4 or .5. It's going to point to this virtual IP that I have, 20.1. In case this goes down, the first hop redundancy protocol, these two routers are talking to each other. RY will find out that RX is down. It will take over the .1 address and the virtual MAC address. So now, from the perspective of the PCs, the end devices, they still are using 20.1 as the default gateway, but now who's going to answer for that? RY, because RY knows RX is down. That's the job of the FHRP protocol, all right? To establish a relationship between the two routers so they keep track of each other, they share the same IP and MAC addresses. So for the end devices, the default gateway will be pointed to the virtual IP, the common shared IP between the two routers, rather than the physical address of, or the actual assigned IP address of the routers. So let's take a look at this. The issue is that the PCs and stations will need to be configured with a single default gateway, and if that device goes down, guess what? You need to reconfigure the PCs. We talked about that. FHRP protocol or technology will allow the two routers to share a single virtual IP address and also your MAC address. So it will be basically a single shared IP and MAC combination. So they'll have virtual IP or virtual MAC combination. The only one that is the active router will answer if a client sends a MAC, like an ARP request for the IP address, the default gateway IP address. The active device will respond back, and he's the one that will actually be the forwarding router for that particular IP and MAC. You have the ability to specify which router is the preferred router. You can change the priority to specify it. So that way you have one of the devices, the preferred device, as the forwarding router. Now, FHRP, as I told you, is not really an actual implementation, it's a technology. The actual implementation of for FHRP are, these are the two different ones that you actually implement FHRP, which are HSRP, Cisco proprietary, and you have VRRP, which is the open standard. So all different vendors support that. The Cisco device can communicate to a non-Cisco device for it. So that's what this is all about. The FHRP is all about. So it's really not an actual implementation. It's a concept. The actual implementers are either HSRP or VRRP. So let's take a look briefly look at the two protocols and subtle differences between the two, besides one being Cisco proprietary, the other one being open standard. That's one of the differences. HSRP will allow two or more devices to work in a group by sharing a single IP and a single MAC address. The virtual IP address is configured on the end user's device, so when the ARP happens, it's going to be pointing towards this guy, the active router. Now, the active router in HSRP is known as the, well, actually the forwarding router in HSRP is known as the active router. The other router is known as the standby router. So the forwarding router is the active router, the backup router is known as the standby router. Now, in HSRP, one of the differences between HSRP and VRRP, in HSRP you can have one active and one standby. Let's say you wanted to have more redundancy and have 3 routers as the exit points from your segment. One will be active, one will be standby. The rest of them, if you have more than 2, will be in a state known as listen. Very similar to that DR BDR concept. You'll have one DR, one BDR, and the others will be DR others. Just in case one of those goes down, the DR other will become the BDR. But again, it needs an election for that. This one, active standby, and the other ones will be listening routers. That's one of the differences besides the, besides one being Cisco proprietary, the other one being open standard. The other subtle difference is the default timers. By default, HSRP will send a hello to its neighboring router every 3 seconds. And if it doesn't see a hello packet coming back from the other device within 10 seconds, which is the hold down, the default hold down time, the active router will say, hey, the standby router will say, hey, the active router is not there anymore. I'll assume the role of the active router. So the timers are 3 seconds and 10 seconds. So to set it again, to review HSRP, again, HSRP is a Cisco proprietary protocol for the fault tolerance for your default gateway. One address, one device, the forwarding device is known as the active device. The backup device is known as the standby device. Both of them will share the single virtual IP address, also known as the VIP, and a single virtual MAC address between them. So when the clients do an ARP for the default gateway, the active router is the one that's going to respond back. In HSRP, you're going to have one active, one standby. If you have more than 2 exit points, the other devices will be in the listen state. So one active, one standby, the rest of them are in listening state. The default hello timers for HSRP are 3 seconds for the hello, 10 seconds for the hold down. Now that's HSRP, hot standby router protocol. The other one that you have is the open standard protocol, which is called VRRP. I need to fix this. VRRP and this, as I said, the difference is that it's an open standard protocol. It's not a Cisco proprietary protocol, so you can run it between a Cisco router and a non-Cisco router. Other than that, the functionality that it offers is the same. Now, the difference in the way it works, first of all, terminology wise, you know, the forwarding router in HSRP was called the active router. Here, the forwarding router is called the master. And the backup router is actually called the backup router. So you have one master, and the backup router is known as a backup router. Now, the difference over here is that in VRRP, you can have multiple backup routers. You know, you're not limited to one active, one standby, as was the case with HSRP. With VRRP, you can have one master and as many backup routers that you want to have if you have exit points. Generally not that big of a deal, but that's the way it works. The other difference is the hello interval. The hello interval for VRRP is 1 second. The dead is 3 seconds. Those are defaults which could be manipulated. So to recap, if I had to do a comparison between the two, HSRP, Cisco proprietary, VRRP, open standard. HSRP, one active, one standby, and you can have multiple what? Listen routers. Here, one master, which is your active router, the forwarding router, and multiple what? Backups. 2. Number 3 characteristic as a comparison is your what do you call it? The hello and dead intervals. Hello is 3 seconds. Dead, which is also known as a hold down, hold time, is 10. Here, hello is 1, and hold down, which is like your dead, is 3 seconds. All right. So terminology wise as well, forwarding is what? Active. Backup is standby. Here, the forwarding is not called active, it's called master. Backups are called backups. All right. So in this video, my main objective was to introduce the technology and make you aware the two different varying technologies that you have. In the next video, we're going to be taking a look at one video for HSRP's implementation, another video for VRRP's implementation. Join you. Hope to see you guys in that video. Thanks for joining.